So let's start from the definition of the algorithm. Algorithm is procedure that gets a value on the input, process it, and produce some value as an output. An example of algorithm can be the next one. For example, we have sequence of input like 4, 1, 2, and 3. A sorting algorithm returns an output of the sequence like 1, 2, 3, and 4. Simple. Instance of a problem consists of the input needed to compute solution for the problem. Algorithm can be correct and incorrect. Correct algorithm is the one that solves given computational problem. An incorrect algorithm might not solve at all some problem or might have an answer for other than the desired one. But sometimes incorrect algorithm can be useful too, in the case when their error rate can be controlled. However, we shall concern only with the correct algorithm. There are a lot of problems that solved by algorithm. Example of a problem which can be solved include finding good route on which data will travel, public key cryptography, and digital signature among the technologies that are based on numerical algorithm and number theory. Many other problems like company may wish to know whether their product, whether they can maximize their product, and also the election candidates want to determine where to spend money by campaign advertising in order to maximize the chances of winning the election, and a lot of other problems. There are two characteristics that are common to many of interesting algorithms, and finding one of them that we do want can be a challenge. The second thing is there are practical applications. For example, finding shortest path can save for company that provides service for delivery packages money, because their truck will need to spend less time on road and packages will be delivered quicker. The next thing is data structure. So it's a way to store and organize data to get quick and easy access to it. It is important to know that no single data structure works well for all purposes, and so it is important to know also the strengths and limitations of several of them. Majority of algorithms that we are going to talk about are efficient. The measure of efficiency is speed. So how long does it take for algorithm to procedure the result? However, there are some problems of which efficiency is not known. Those problems are known as NP-complete. There are few things about NP-complete problems. First, it is unknown whether or not efficient algorithm exists for NP-complete problems. Second, the set of NP-complete problems has the remarkable property that if an efficient algorithm exists for any of them, then this means that there are algorithms that exist for all of them. And third one, several NP-complete problems are similar but not identical to problems to which we do know of efficient algorithm. A small change to the problem statement can cause a big change to the efficiency of best-known algorithm. So it is important to know about NP-complete problems because some of them are surprisingly often occurs in real applications. If you can show that the problem is NP-complete, you can instead spend your time developing an efficient algorithm that gives a good result, but maybe not the best possible solution. The example of NP-complete problem is the traveling-salesman problem. The example of salesman problem can be the next one. There is a trucking company with a central warehouse. Each day, company sends its truck from warehouse to set it around the several locations to make deliveries. At the end of the day, truck must end up back at the warehouse so that it is ready to be prepared to the next day delivery. To reduce cost, the company wants to select an order of delivery stops that yields the lowest overall distance traveled by the truck. This problem has no known official algorithm, and under certain assumptions, however, there are official algorithms that give an overall distance that is not too far above the smallest possible, but not the best one. And the last thing that I wanted to tell you about algorithm is that the total system performance depends on choosing official algorithm as much as on choosing fast hardware. Now let's summarize what we talked about. First, we discussed about what is algorithm, what is instance of a problem, the definition of correct algorithm, incorrect algorithm. Also, we talked about some kind of problems that are solved by algorithm, and also we discussed the characteristics that are common for many algorithms, what is data structure, and also we learned about NP-complete problem, which is also called Traveling-salesman problem. And that is it from this video.